Welcome back to the contest, dear watchers. Our next three participants, Aryaman Arora, Andrew Gargiulo, and Anthony Vincens, come from the Athene, and they attempted to use artificial intelligence to predict earthquakes. Earthquakes have impacted around 125 million people over the past 20 years, and many, many more throughout history, which is why this team's main goal was to be able to provide accurate predictions as far in advance as possible to be better prepared for earthquakes. Welcome on stage.
Using artificial intelligence to detect earthquakes with seismographic data. As said before, earthquakes have impacted around 125 million people over the past 20 years. Every lost life to an earthquake can simply be avoided with the correct knowledge in advance. That is why our main goal in this project is to provide accurate predictions to when an earthquake can hit as far in advance as possible. Artificial intelligence is the next step in the field of earthquake prediction and analysis of trends over time. This research project attempts to utilize noise data to predict laboratory earthquakes. The data set we are using to get seismographic data is from Los Alamos National Laboratory in California. The laboratory experiments consist of two gauge layers which are sheared simultaneously while being subjected to a constant normal load in between and a prescribed shear velocity pushing inwards. This generally represents a convergent tectonic movement. The laboratory faults fail in repetitive cycles of stick and slip that is meant to mimic the cycle of loading and failure on tectonic faults. While the experiment is considerably simpler than a fault in Earth, it shares many of the same characteristics, physical characteristics. The seismic data is recorded using a piezo ceramic sensor, which outputs a voltage upon deformation by incoming seismic waves. The seismic data of the input is in this recorded voltage is in integers. The data file has two separate columns. One represents the acoustic data that has been recorded, and the other, the time to the next earthquake, denoted as time to failure.
Very simply, a neural network is a type of function which can convert one kind of variable into another kind of variable. So an example would be a picture of a cat would be converted into a prediction of what this image really is. So for our model, we had to use an LSTM architecture for our neural network, as in a typical recurrent neural network, we would have to deal with the vanishing gradient problem. So this problem is created because over iterations, the weight would be multiplied by itself over and over again. So if we had an original variable x and we multiplied it by the weight w over and over again, it would tend to infinity if the weight is greater than 1. So our algorithm has several key steps. So after loading the data, we generate the batches and standardize the data. So this is the pre-processing phase. After running, all the scores are calculated by the mean average error, which we would calculate by seeing how close our model was to the actual time the earthquake occurred. So each model, or each earthquake in our model is represented by 150,000 rows at 4 megahertz, which is how the instrument in the experiment was used to calculate. And this would represent an earthquake every 0.0375 seconds. So our results would really represent how much we were off. So one thing that we really had to avoid was the over-analysis of data. So we really didn't want to overanalyze the data, meaning that our AI would memorize the actual data set rather than learning how to deal or predict. So to avoid this, we created a methodology, and this would be where we would test different batch sizes, different neurons, or the different numbers of neurons, and different epoch amounts. So generally, the point was to see and make sure that our accuracy was as high as possible. And at the very end, our model reached an accuracy of 98% mean average error, or mean average accuracy, meaning that in real life, when we converted from the megahertz, we would be approximately 14 hours off an earthquake prediction. So for the experiments, as we can see with the epoch sizes, there's a huge increase in accuracy when we move from 10 to 50 to 100. And when we compare the batch sizes, it didn't really seem to matter as much. So we maintained the 1, which has the highest accuracy. And then finally, with the neurons, the difference between 4 and 6 does not seem to be enough to in exchange for the higher amount of computational power it would have been required to run the AI.
Generally, on average, the earthquakes all share similar acoustic averages before earthquakes actually happen. This is, however, different in real life because of the different seismographic trends, different locations, and also different geological materials. We have to also consider the density of the lithosphere in the ground that could adjust the readings. For our project, we use one source of data that contained 4,096 earthquakes. The next step is to convert the actual seismographic data into simple numerical values, which is achievable and has been done before. Our model is extremely flexible and adaptable. We're able to adapt our code to the 3 different tectonic plates and keep the LSTM model. Right now, as mentioned before, we have a 98% accuracy and are able to predict at a minimum 14.4 hours ahead of when an earthquake happens. Now imagine if we could apply that to real life, how many lives we could save. Finally, a potential expansion of the project would be to predict when different tsunamis could occur. And here are the sources we used, and we'd like to thank you all for listening to our presentation.
Thank you guys for joining me here. How did the 3 of you know each other? Where do you know each other from?
Should I answer this? Yeah, go ahead. All 3 of us are classmates. We're in the same class at the Nationale de Luxembourg.
Yeah. And you've been in the same class for a while?
It's our 3rd year?
This is our 3rd year. He's been here since Cesium. Yeah.
And how did you come up with doing this project? How did that come about?
So we're great fans of chemistry. So we're all doing chemistry HL, and we really, I think we all like the geology aspect of our chemistry class. So we were like, why not do this?
But if you look at the project, you know, like when people think about earthquakes and like analysis that goes with it, like it's actually, to me, it's pretty intimidating. It's just, I imagine a huge set of data that can go in every direction possible with thousands of different scenarios. Was it intimidating for you to start such a project?
Should I answer? Well, I mean, for us, it was just mainly, it was more interesting than it was intimidating because we were just looking at the data set, and since we also love math, we just found it very fascinating, very interesting.
And how did you find out about the data that is available to look at?
So I've heard of this website called Kaggle, and we found this nice data set from the Los Alamos Institute. So we were able to really acquire some really good data.
Did you start the project because you found the data, or did you start the project and then we're looking for appropriate data to back up the actual idea?
Well, I mean, first of all, it was interest, and then we were able to find the data set off of that.
So yeah, we specifically looked up for some seismic data after we thought like this would be a really fun idea. So.
And as I said, it's probably a huge set of data and probably going in every direction. Like, did you were you alone doing that and then digging into that and trying to find did you get some help for that?
Well, I mean, we all did it. Like us 3 researched the
okay.
entire project by ourselves. So.
Impressive.
Yeah. And then in terms of the data, it's enormous. It was a 9 gigabyte file or something for Excel, just 6 million something rows or something.
I guess, yes.
It was definitely intimidating, but we had a lot of fun.
What was it like working together in a team?
You can say it, go ahead.
Sometimes it was hard because it was getting annoying when we didn't find what we wanted to find, but you just push through and we always support each other. So.
Did you have specific roles within the project, or like did you really work all together and developing all at the same time?
Yeah, he did mostly the coding and the AI, and we did the research presentation.
Mm-hmm.
Okay.
Yeah.
And Andrew made the graphs and everything for the presentation and the research paper.
And how long since starting on the project until completing it?
Oof.
When did you start? When did you first start?
I mean, we started like at least December.
I think last year or something.
Yeah.
Quite a while.
Was it time consuming overall?
I mean, we like putting in a bit of consistent effort, but at times we worked harder than other times, so a bit of balance.
Mm-hmm.
How did you juggle the work that needs to be done on the project and your schoolwork and other commitments?
Do you want to answer?
Yeah, well, at school we have a different timetable than other students. We have a bunch of holes in so we have 2-hour breaks, so we usually did in that time.
So you could use some of that time to then work on the project and so on. Yeah.
Mm-hmm.
And is this the first time that any of you participated in the contest?
No, last year us two did a project on license plates.
Okay.
Yeah.
Mm-hmm.
And this year
This
you
is
joined
my first time. Yeah.
the team. How does the experience compare from last year and then this year?
I think it's this year. It's going to be a lot more fun, especially tomorrow or on Sunday when we get to see everyone and less masks, of course.
Yeah.
So.
Yeah.
I have a question for you then.
Yes.
It's like, how did they convince you to jump in this time?
Oh, well, I mean, I heard about when they did the project last year on the license plate, and that was just really interesting to me, and I just wanted to hop in, and it's a new experience, so it was just something that as soon as I heard about it, I was like, I want to get in. I want to jump into the next project.
Did you have a look at their project in detail from last year?
I did actually, and yeah, I like the idea. So joining the team was good.
Okay. And the original input, like from going to license plate to earthquake, who had the idea?
Well, I think all of us, we kind of wanted to do something on earthquakes.
Mm-hmm.
And
because of the interest of geology.
Yeah.
And I obviously, as we wanted to do something on earthquakes, I had the coding knowledge so that we can actually do something. It's a bit similar as well to last year, as we also did an AI detecting the license plate and making a system behind this. So I felt like our idea, along with some coding, would be a really cool idea to make.
Okay.
Well, thank you very much for your time.
Thank you.